This is a Algebra 1 video on Chapter 6, Section 1, which is solving systems of linear equations by graphing. So a system of linear equations is two or more equations containing two or more variables. Basically, it's two lines that either meet or don't meet. So what I mean by that is, here's an XY axis. There's going to be two lines. See, either they're going to meet somewhere, or they are going to be parallel and not meet. So there's one more situation, and that is if they are the same line. Say, like if you have one line and then you have another line on top of it. Those two situations, this one and this one, are weird, but they're real. Okay? So what this is an ordered pair that's common with both equations. All right? So there's an ordered pair that makes both equations true. So what you have to do is substitute the x and the y into this x and this y, this x and this y, into both of these equations to see if it's true. So let's do it. The directions are tell whether the ordered pair is a solution of the given system. So we're going to substitute this x and this y in here, 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 and here. So we're going to write, I'm just going to fill in my equation here, use different colors, okay? Okay, so I put a 2 in here. 2 equals 4 times 3, which is the y, minus 10. Now I'll figure that out. 2 equals 12 minus 10. The 12 came from the 4 times 3. And this is true. Okay, so let's substitute them in the next equation. 3 times x, which was 2, plus 7 times 3 equals 27. Well, let's see. 6 plus 21, 6 plus 21 equals 27. Well, that's true. So the answer to A is yes. B, though, might be different, it might not be. So let's check it out. This is x, and this is y. I'm going to get fancy with the reds and the blues, so we're going to put 5 in for this y, and we're going to put 1 in for this x. Okay? So we will write 5 equals 4 times 1 plus 1, and that's true. 5 equals 4 times 1 plus 1. And then the next one is 5 minus 3 times 1 equals 4. 5 minus 3, that's 2. And that does not equal 4, so that one's false. So this one is no. So either the ordered pair is the solution, or the ordered pair is the solution, or it's not. And if it is the solution, that means if I graphed both of these lines, they would intersect at this ordered pair. So now we're going to graph an ordered pair that has both two lines, and we're going to see where they intersect. And we're going to use y equals mx plus b. And this is going to be line A. I always do, and this is going to be the one line, and this is going to be line B. So I can do A and B, but we got to keep them separate. So let's go ahead and do A. Y equals 1x plus 5. So m equals 1 over 1, and b equals 5. So I go up to 5, and I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and I can even go negative 1 over negative 1, negative 1 over negative 1. It's okay. And I'm going to draw that line. Now I'm going to do the next one, and that is m equals 3 and b equals negative 1. I'm going to put a point at negative 1, and I'm going to go up 3 and over 1, 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 and I'm going to graph the line. Now I did a lot of points to see that this is the intersection point. And that point we figure out. It's 3, 8. 3, 8 is the solution to the system. Okay, so that's what you have to do to solve this system of equations, which is two equations, okay, by graphing. So solve the system, and the system is these two equations. That's what is known as a system. All right, so let's practice, okay? Now, there's going to be 3 more examples we're going to try to get through in this video. Okay, so let's see how this goes for us. We have to write the equation in slope-intercept form first. So for the first equation, I have to subtract the 3x, and I get y equals negative 3x plus 9. So m equals negative 3 over 1, and b is equal to 9. For the next equation, it's solved for y by subtracting the 1x. I get 2y on the left, negative 1x plus 8 on the right. I have to divide by 2, and I get y equals negative 1/2 x plus 4. So the slope of this line is negative 1/2, and the y-intercept is 4. Okay, so let's graph both of those. We're going to graph the brown one first. We're going to get 9 for a y-intercept, and then we're going to go negative 3, 1, 2, 3, positive 1. Negative 3, positive 1. Negative 3, positive 1. So we're going to graph that line. And the purple one next, the y-intercept is 4, and the slope is negative 1 over 2. Oh, look at that, I found a point, yay. Negative 1 over 2, negative 1 over 2. Draw a line, sort of circle that intersection point, and let's go ahead and write it down. Give me an answer. Positive 2, positive 3. Right? X equals 2 and y equals 3. Okay, so that's one, and then let's move on to a couple more. Okay, I think we're going to do this one here. All right. We'll do B because we don't have a lot of time. All right, so the first equation, it's already solved for y. Y equals 3x plus 2, so m equals 3 over 1, and b equals 2. Now, the next equation is not solved for y yet, so I got to divide by 2. So I get y equals 3x plus 2. Now, if you don't recognize already, these are the same lines, and I'll tell you what's going to happen. So these are the same lines, right? All right, well, let's see what happens. We're going to graph the brown line first, where we get 2, and then up 3 over 1, up 3 over 1. And then we're going to graph the purple line, where we get the same line, up 3 over 1, up 3 over 1. So when it's the same line, there's infinite solutions. When two identical lines are given, infinite solutions is the answer. Is the answer. Okay? All right. All right, so we do have time for one more. So this B is infinite solutions. All right, let's look at this one. Let's graph this one here. We're going to subtract the x first, solve for y. So I have negative 2y is equal to negative 1x plus 8. Divide by negative 2. Y equals 1/2 x minus 4. All right, and this problem is actually already done. Right? This equation, y equals 1/2 x. So m equals 1/2, b equals 0. All right, so let's graph the red one first. B equals 0, which is right here. Positive 1 over 2 is what I get here. Positive 1 over 2, positive 1 over 2. And I graph it. And the next thing we'll do is graph the black line. The y-intercept is negative 4. So I plot negative 4 right here. B equals equal to negative 4. And so I go up 1 over 2, up 1 over 2, up 1 over 2. Graph. We can see that these are parallel, so there's no solution. So parallel, which is same slope. All right, you see the slopes? Both the same. So this, when two lines are parallel, there is no solution. All right, so that sums it up. We're going to be looking at Chapter 6 today in Zoom class, but starting with 6.1, solving systems, there's 3 possibilities. It's either the same line twice, or one solution where the lines intersect, or no solution where they are parallel. So the first, though, we have to see that if an ordered pair is the intersection. And we did that by substituting. And then we graphed one with one solution, and then we graphed another one with one solution, but we had to solve for y. And then we had our 2 special cases right there. All right, a good day.